Problem B3. Quality Quest. The quality factor is a dimensionless number which quantifies how efficiently a system stores energy, and how strongly it responds on resonance. For a circuit consisting of a capacitor C, an inductor L, and a small resistance R in series, the resonant frequency is approximately omega 0 equals 1 over square root from LC, and the quality factor, assumed to be large throughout this problem, is Q equals 1 over R multiplied by square root from L over C. In this problem, we explore several ways to measure Q. Uncertainty analysis is not required. Question A. Alice measures Q by seeing how oscillations in the circuit damp over time. Suppose that initially the charge on the capacitor is Q and the current is 0. The next time the current is 0, the charge is negative Q multiplied by 1 minus delta. Find an approximate expression for delta, in terms of omega 0 and Q. Question B. Bob and Charles drive their circuits with a sinusoidal voltage Vt equals V0 cosine omega t. It can be shown that in the steady state, the voltage across the capacitor oscillates with amplitude in the expression 1. The circuits Bob and Charles have are similar, but are not precisely the same. Part 1. Bob fixes the value of V0 so that the highest value of V, C, at any frequency is precisely 10.00 volts. His equipment can precisely compare the amplitudes of a small DC and AC voltage. He thus performs two very accurate voltage measurements given in Table 2. Using this data, find the numeric values of Q and omega 0 as accurately as possible. Part 2. Charles can precisely tune omega, but cannot precisely measure small voltages. He thus fixes V0 to some other value and takes data near the resonance, where Vc is relatively large. Table 3. Using this data, find the numeric values of Q and omega 0 as accurately as possible. Hint: you may use the graph paper in the answer sheets, but full credit is attainable without graphing. To find Q, you should first find omega 0, then simplify the equation above using omega approximately equal omega 0. Question C. The gain function of this circuit is defined as G equals VR over V0, where VR is the amplitude of the voltage across the resistor, as shown in Figure 4. Part 1. Find an expression for G in terms of omega, omega 0, and Q. Part 2. This setup can be used to reject voltages at certain frequencies. Qualitatively describe the ranges of frequencies for which G is small.